We're live.
I'm Katie Klotz, the Community Manager at RoboNation. Thank you for joining us for the Welcome to GoSense webinar today. At RoboNation, we know that students learn best when they can dig in and try things for themselves. GoSense is our new sensor kit designed to help you bring real science and hands-on exploration into your classroom, club, or program. Today, you'll hear from David Young, our Product Manager, and Jamie Barnes, our Product Design Engineer, who will give you a look at how GoSense works, share practical ideas, and answer your questions about using it with students. Feel free to use the chat to ask questions or share your own experiences throughout the webinar. We're excited to hear what you think. And with that, I'll hand it over to David and Jamie to get us started.
Great. Hello. Welcome. I am David Young. I am the product manager. As Katie said, I've worked for RoboNation for over 7 years now, and GoSense has been one of my, I guess, most fun endeavors since I've been here. So we're happy to give this presentation today on the GoSense ecosystem. Jamie?
Yeah, I'm Jamie Barnes. I'm the product design engineer. I've been at RoboNation for about 1.5 years, but before that, I was a student in some of the other programs that RoboNation puts on. So it's very cool to be here.
So GoSense is, we consider it a whole ecosystem. It includes environmental sensors, our new Air Plus sensor, and the marine sensor. And then they are both expandable platforms, so they can be expanded for different sensors to include different environments with an open source software suite. So you can modify it yourself if you're able to do that. And we have educational resources, which are a curriculum that is tied to standards. And then we have collaboration platforms and different means of sharing data. And now we head over to the GoSense Air Plus sensor, and we'll pass it to Jamie.
Thanks, David. This is just a quick call out of all of the things that the Air Plus sensor has. The highlights here are a OLED data display that gives you real-time data readings from the sensors. The sensors that it ships with are a pressure, temperature, and humidity sensor, as well as a UV sensor. And then inside that sensor enclosure, there are additional mounting holes that fit a lot of standard mounting hole patterns from sensors that come from companies like Adafruit. So that really helps with the expandability aspect of this sensor. When you first get your GoSense Air Plus and you plug it into the Arduino IDE, which is just how we are interfacing with it, you can get a live serial reading of the data, and you can configure your GoSense, which is very important because the real-time clock that is on these systems isn't necessarily synced to the correct time. And the time and location are things that are saved as your file name. So if you wanted to look up your data later, if you don't configure your GoSense to be the location and the correct date and time, you're probably looking at default 2085 year, and you're just going to have a really hard time finding your data. So to do that, you can plug it into the Arduino IDE, and in the serial monitor, just open the menu using M. And then there's various options like changing the location, which is just like kind of a description for you, your latitude and longitude, date and time. And then other things that you can change are the sample delay, so how long between collections, and then also how many samples you want to take. You can set it to take a limited number of samples or specify if you only want to take 5 or 10.
And with the Air Plus, there are a lot of different experiments and different applications for it. You could do daily temperature, humidity, pressure, and UV readings over a period of time. You could do it throughout the day. So you would configure your sensor. Say if you're going to do it, you want to measure data over a whole month, and you're going to go outside every day around the same time. You might set your sampling rate to something fairly high, like every minute, every 5 minutes. Leave it out in the, just go outside with it, capture some data at a certain time, and then you'll have multiple files that you can add together. You can look at those in Excel, or we'll show you some of the data platforms in a little bit. But you could observe kind of temperature and environmental changes over time. Air pressure, you can get altitude. That's not a measurement that we save, because Jamie will show you in a moment. You actually need to do a little bit of math to get altitude from air pressure. But it's a pretty good experiment for students, even if you want to just demonstrate and you're in a two-story building or somewhere that you're near hills, that you can start off at a certain altitude and then go up and then bring your data back. You can look at that, and it's really good to show the students the how these two things are related to each other, that altitude is actually related to air pressure. And UV, the same with daily temperature readings. You could get UV readings throughout a single day. You might go out every day and get some UV readings. And we do want to mention, with the GoSense Air Plus sensor, the protective cover that is on the external sensor housing has a small clear lens in it for the UV sensor. If you remove that whole cover, your UV sensing will be a lot more accurate. Your readings will be more accurate, because that sensor, even the lens, even though it's clear, it does block some UV light. And, in order for us not to find a lens that would not block, it would be extremely expensive to do. So we've chosen to go this route, but a simple fix. And we provided a UVindex.app is a website that you can put your city or your zip code in, get your current UV, get UV over the period of a day. There are a lot of different websites you can look up. So, really, if you're getting UV, look something up and see what it's supposed to be. Same with temperature. You can calibrate it by using a known temperature sensor and just kind of validate your readings.
So what does the data look like once you've collected data? The data is saved onto the micro SD card that is installed in your GoSense Air Plus, and it is saved as a CSV file with all of the standard readings saved as headers. If you'll notice this first blank column that says EC5 UUID, that is for using it with one of the data sharing platforms that we'll talk about a little bit later. But if you intend to use that, you'll want to keep that column blank. But you can see the location description that is in the configuration, as well as latitude, longitude, date, and time, all get shared, and then all of the data you collected. As David was talking about, there's a relationship between pressure and altitude. So I just pulled this into a spreadsheet and used this formula provided by NOAA to convert from the pressure to the altitude. I'm in Southwest Virginia. We generally say we're about 1,800 feet above sea level. So the altitude that was calculated at 1771 is pretty good. When you take this out to the field, you'll want to make sure that you have batteries charged. The AirPlus ships with 4 AA nickel metal hydride rechargeable batteries and a battery charger. It only requires 2 at a time, but if you charge all 4, you can quickly swap them out if you need to. But it should continuously record for up to 24 hours, so you shouldn't have to change the batteries very often. You'll want to make sure the micro SD card is inserted, since if you've just collected and you're uploading it on your computer, you'll want to make sure that's in there. If it's not, it will actually not let you collect data, and there will be a troubleshooting message on the OLED display that says that you'll need to insert the SD card. Then you'll want to configure the GoSense, like I mentioned earlier, making sure your date, time, location is all set up, and as well as how often and how many samples you want to take. When you power on the GoSense for the first, or anytime you power on the GoSense, the OLED display will show you the configuration that you have already set on the SD card. So that's just a great place to double check if you needed to change something and it hasn't been changed yet. You can go change it on the computer before you start collecting. And then you just hit the record button to dismiss that screen and start seeing the live data. And then you can hit the record button again to start recording the data. And that record button will blink red to let you know that you're recording.
And the GoSense marine sensor, created for marine sensing, lakes, ponds, rivers, oceans, seas, you name it. So it's been all over. We'll show you kind of where it's been in a little bit. So the temperature, it comes with a temperature sensor and pressure sensor. And in the instance of the marine sensor, we use pressure to calculate depth. So as is completely opposite from the GoSense Air Plus, but still it's a relationship. So that's why everyone that will probably ever make will have a pressure sensor on it. We also offer a turbidity sensor for water clarity and a dissolved solids sensor. These are optional add-ons. And a couple things that are different. This is made for marine environment, so it's totally sealed. It's been tested and rated for about 225 foot depth in seawater. That's about 100 pounds per square inch of force. This has a magnetic power button, which we'll show in a little bit how to turn it on. All of this is in the guides. So, if you have questions on these specific things, we won't cover everything, as Jamie didn't cover every detail of the Air Plus, but these are in our quick start guides plus our user guide. So this has the micro SD card and a USB port, which you have to remove the lower end cap if you want access to those. So for removing and inserting the SD card and for plugging it into a computer, you remove the end cap. If you want to change the battery, you have to open up the other side of the sensor and pull the whole unit out of the pressure tube so you can change the battery. It comes with the same batteries that the Air Plus does, comes with 4 batteries and a battery charger. In the lower section, we show that there's some extra ports on it, and that's what makes it configurable. So if you have your own sensors, you can connect those, reprogram it, and you're off, sensing other parameters than we've designed it for. And this is just an example of installing the additional sensors. Not very difficult at all. You remove the blank penetrator plugs and then screw the sensors in, connect them to the printed circuit board. And then in the configuration, the software is already there, already programmed to measure these. You just have to set the software to tell the GoSense that it has these 2 sensors added to it.
That's a great segue into what does the configuration menu look like for the marine sensor. A lot of the same parameters like location, latitude, longitude, and time. And again, you'll want to make sure that you configure that before you ever take it out for testing. And then also double check, especially if it's been a while since you've used your GoSense Marine, double check that the time is still synced with the world clock online. Just because some of these sensors, like the real-time clock, does tend to drift a little bit over a long period of time. So if you're really looking for super accurate time sync, that's something that you'll want to check. The differences here between the air and the marine sensor in configuration is setting the water type to fresh or salt, which has impact on the depth readings. And then also configuring whether or not you have the TDS and or turbidity sensors installed. These are automatically turned off when you get it, as all the marine sensors ship without these 2 sensors installed, but you can easily configure using the menu in the Arduino IDE. How do you know that things are working? Without the OLED display like the Air Plus, it's a little bit harder to tell and get feedback from what's happening. The video on the left shows what it looks like if you've successfully started recording. So there's the magnet near those lights, or the read switch near the lights, that's the power switch. You put a magnet near it to turn it on. It'll wait a couple of seconds for you to lower it into the water, and then it'll start blinking a slow blink at 1 second. If there's an error, such as your SD card is not inserted, the blink will be very fast and angry to try and remind you that there isn't an SD card and it is not recording. The applications are very numerous in the marine world as well. One of the applications over a length of time is a depth profile. So you can take your GoSense Marine and it has a lanyard and you can attach a string on it to slowly lower it in a body of water. And you can get a smooth profile of what the temperature is as you get deeper in the water, as well as any other parameters like TDS or turbidity, and see how that changes with depth. You can also do classroom experiments to understand what turbidity or TDS really means. So this picture shows adding cocoa powder to water to make it less clear and seeing how that affects the turbidity readings, as well as using electrolyte solutions to dilute it in water and seeing how that changes the total dissolved solid content in your system. In the real world, getting to observe TDS and turbidity after a rainstorm shows what kind of impacts runoff have and how that's affecting your environment.
And this is a data plotter. So Jamie showed what the data looks like in Excel, and you can definitely plot data in Excel. You can plot it in a lot of different applications, but this is kind of a convenience program that we created. It does not need to be online. So it runs in a browser. There's no installation necessary. And it's a lot faster to actually be able to look at your data instead of using Excel, have to select ranges, choose your plot. So it's all built in already. You select the file that you want to look at, then you select the type of display that you want. The one shown here is the same one that was on the other slide, but it is temperature and total dissolved solids over depth. You could change this to a time series, which is what most people are used to looking at, where you have a range of data just simply over time. All the data displays have two axes, so you could look at temperature and humidity on the same graph, just like this is temperature and total dissolved solids, where you're seeing the accurate scale for both of those different values, even though they have different scales. So very configurable. You can zoom in, you can do a lot of different things. You could save this image. So just a convenience program that we created free of charge for our community. Not sure that it's actually available in GitBook yet, where the other program that we'll show you in a second is, and where our user guide is, but it will be very soon. And then field testing, same as with the Air Plus, charge your batteries, charge all four of them. Then you have two batteries to use. You can swap them out if you're in the field and your batteries die. Inserting the micro SD card, of course, you need to do that really before you go out in the field. Seal the sensor up completely, take it out. Well, you've already, at that point, then configure it as Jamie showed the configuration. So when you're assembling it, make sure there's no debris, hair, dust, anything that could be on the O-ring surface of the tube or on the O-ring of the end caps. Very important. A leak is going to mean you get water in your sensor and you'll probably ruin your sensor. So look for cracks in the plastic case. And finally, when you get to wherever you're going to use it, lower it into water very slowly, just a foot deep or just, 6 inches deep into water. Shake it off a little bit so surface bubbles come off, and make sure there's no bubbles coming out of the sensor and that there's no water going in. Once that's done, you're good to go. You can power it, as Jamie's video showed, with turning it on with the magnetic switch, with a magnet on the magnetic switch. And as soon as you turn it on, it starts recording data in, I think, 10 seconds. So then you're good to go. When you're finished, bring it out and then turn it off with the magnet.
So because the code is open source, there might be changes that you want to make or changes that we make that we want to push out to the units that will let you know if you have one. And it's really easy to reflash the firmware onto your system. So both the GoSense Air Plus and the GoSense Marine have a Raspberry Pi Pico microcontroller. That's kind of the brain doing all the work on the printed circuit board for your system. And you'll just have to download the UF2 file that's provided. And when you plug it into your computer, you'll hold the boot select button that's highlighted on these images before you plug it in, hold it, plug it in, let it go. It should show up in your file explorer like any other drive or flash drive that shows up on your computer when you plug it in. And then you can just copy the UF2 file onto it by dragging and dropping, copy and pasting, or however you'd like to do that. And then it's good to go to start collecting data again. One of the biggest questions we've gotten with GoSense Marine is, how do we get it on a vehicle? What can we do to get it integrated with CPerch? So here is just one example of how I mounted it to a CPerch utility build ROV. The first thing you're going to want to do is remove some of that ballast weight. The GoSense Marine is pretty negatively buoyant so that it will sink and you can get those depth profiles. But I already knew that my CPerch was where I wanted to be buoyancy-wise, so I wanted the GoSense Marine to be neutrally buoyant. So when I added it on, it wasn't making a difference in how the vehicle performed. That looked like removing most of that ballast cap weight. And so that, again, is that bottom cap. That is what you would remove to put the SD card in or plug it into your computer. There's 4 screws and a little cover, and you just carefully open that up. I say carefully because this is just loose steel shot. So if you're not super careful, you will end up with tiny steel shot all over the floor. And so I removed most of mine, if not all of it, for my situation, but this is something that you can test with whatever vehicle you're putting it on. Then the GoSense Marine comes with a lanyard mount to attach string to lower it in the water, but you can repurpose this to add cable ties to the mainframe. And then on the bottom, create your own cable tie lanyard mount and attach with more cable ties to the frame. And that's it. You can go drive your CPerch around as you would normally, but collect data while you're doing it. As David said at the beginning of the presentation, one of the things that sets GoSense apart from other environmental sensors that you can get on the market is our great educational resources that exist, thanks to the educational team at RoboNation. So these are available on the website for you. You can go to gosense.org and click on the system that you're using, use the code CPerch, and it'll take you right to those lessons. These lessons have been mapped to national standards for you. So if you're trying to create lesson plans in your classroom and you're required to show how it maps to the standards, it's already done for you. And then this is what a sample lesson plan looks like. And it shows you, again, the standards that are exactly tied to that lesson plan, and these lesson plans build on each other. So it's a great way to seamlessly integrate this into your classroom without a lot of work on your back for you on the back end.
And this is an example. EpiCollect is a free online platform for sharing citizen science type data. So you could create an account. There is a guide, I believe, accessible through the website for how to create your account. Once you do that, you can share that. You can upload your data. We have a sample data set there. I'm not sure if the sample data set right now, if you can actually get map points as in the bottom of the picture, but that is definitely a possibility. So with your own, you can see your points on the map. So if you have multiple data files in different locations, these are actually real data that's being displayed of where the GoSense has been around the country, and those have been uploaded. Then we also created what we call the GoSense Data Map Viewer, or Data Viewer, and this is very similar, but it does not require an online account, does not require installation on a computer. It runs in a browser. It is just a simple HTML file that you download from Gitbook with the user manual for this. It's linked off of our standard user manual. You just download it, double click on it. It has sample data in it already. This is real data that you're seeing on the map. It spans all over from Sarasota, Florida, Virginia, Boise, Idaho. GoSense has also been to Canada collecting data. So it's been all over the place. And this, again, is another we're providing this for free to the community, just as a convenience. You want to look at data quickly in your classroom, just open this and look at your data. You can upload it or look at the sample data that exists. If you do have an internet connection, you can click the button that says get my location, and it will put a map point for where or close to your location or where your internet browser is telling it your location is. Then you can actually click on that point and it will give you the temperature at that location. You can add map points. So that's important when you're going to collect data. You could use this, add a map point, add it to your present location. It will show you the latitude and longitude for that location. You could actually use this program as well for setting or looking at when you're setting your clock. If it has an internet connection, it does sync to an internet clock. If it doesn't, it syncs to your computer clock. So just a very handy program for looking at multiple data files at the same time, clicking on them and seeing the underlying data that's shown in the table in the bottom. And then GoSense in the wild, it's been all over. It's been, as I said, San Francisco. Jamie's had it in the San Francisco Bay. I've had it in the Rocky Mountains. I've had it at the headwaters of the Colorado River. The picture on the right center is Blue Robotics. Took it out on a blue ROV. They mounted the GoSense sensor and went and collected data. Interesting story on this is they're very expensive. Not sure what turbidity sensor they were using. It had a problem and failed, but they accurately collected good data with the GoSense sensor, which is a lot less expensive than the commercial turbidity sensor. So very adaptable to different platforms. Just it's been all over, and we hope that you will take it all over and then share your data with the community.
One of the fun projects that we had the GoSense involved in is with the DoD STEM ambassador we're partnered with. His name is Derek Rashford, and he monitors female bears' dens. And they knew that there was a controlled burn happening nearby. So they actually took the GoSense Air with them into the cave and recorded the data. And he said it's really easy just to strap it to his backpack and let it do the work while he's hiking through the area. So that was a really cool other experiment in the real world. And there's a lot of great ideas from the community about how they can start monitoring their environment, marine or air. These are some of the projects we have on the horizon. We are working on a discovery kit, which is a learning lab to help students learn about the basics of electronics, software, and even some hardware. There will be dedicated educational resources to walk you through this. It could be done in a classroom setting or on your own kind of guide. And it's really to help try to bridge the gap between programs like CPERCH and our autonomy program, so you can get a better feel for the electronics, software, and mechanical side of robotics, really. For the Air Plus, we are working on an expansion pack, which it just snaps onto the existing sensor enclosure with additional I2C ports and a Dallas 1-wire port. I2C ports are pretty common on a lot of plug-and-play sensors from sources like Adafruit again. And this is kind of what we're saying is putting the plus into the Air Plus sensor, because you can plug in a turbidity sensor and look at shallow water, or you could plug in a soil moisture probe and see what is happening in the soil. So it kind of makes it a land and air and maybe even shallow water sensor. And then we're also looking at what other sensors we can create or integrate or provide DIY instructions for you at home to integrate with the GoSense units. There's also, both of these have the Raspberry Pi Pico W, which has wireless capabilities that are not currently enabled in the software, but we're getting to a point where we can enable that so that you don't have to offload the data using the micro SD card, especially with the Marine where you have to open it up and it's a little bit more difficult. So you can get that data without worrying about making sure your SD card is in the unit or not in the unit or losing it because it's a tiny micro SD card. So really excited about that opportunity as well.
Great. And that concludes our presentation. We hope that someone has questions. If you do, we're here to answer them now. If not, you can shoot us an email. Our address is here in the GoSense and RoboNation website. So make sure you check out all the RoboNation programs, and especially head over to GoSense.org, check out what we have there. If you're interested in resources, that's where you find everything. That's where you find the links to other sources. So thank you very much.
Thank you both. The chat has been active, so we have a lot of questions for you. The first is from CMAC, and this is with regard to the Air Plus sensor. Will you put a GPS into it, or could you add your own through the expandability options you mentioned so that it automatically tracks its own location?
I'll take that one on. I've already done that. Just as a proof of concept, I bought a very inexpensive GPS module, connected it, hacked the connector for it actually. So, but yes, very possible, easy to do actually, and then easy to program and capture that GPS data. So these are some things that we want to develop guides for the community. You know, we may or may not offer some sensors, but the ones that we don't, we do want to have some guides on how-tos. So it's great to hear that someone's done that and asking questions. So we kind of know what the community wants and what we can provide. But yes, very easy to do. Was there a second part of that question, Katie? Besides just
that was,
okay.
Nope, that was it. Thank you. Thank
Sure.
you. Okay, now we have a question from Yusuf about the Air Plus control, the Air Plus sensor. Is the Air Plus a controller? So are there any maybe capabilities that would lend itself to a CPERT, something like that?
It is not right now. Now, we do have on our roadmap connecting it to the GoSense Marine. So you could have live data displayed on the GoSense Air from the GoSense Marine with a cable, not wirelessly. There are capabilities within the Pico to control things. So, you know, you could, you know, if you're the maker, tinker, hacker type, you could definitely add those capabilities. Jamie, what do you think you could do if you, what could you control with it maybe? You got any ideas?
I don't know right now, but that's yeah, I hadn't considered using it as a controller, but it's exciting.
So you could, I mean, typically, you know, people use microcontrollers to control servo motors. There's no switches built into it, but I guess you could certainly add some switches for that. So, you know, a lot of capabilities. We'd love to hear what these ideas, and then we'd love to see somehow emailing us if you're already interested in doing something. If you started doing something like this would be great to find out.
Mm-hmm. Even like controlling blinds or something in your house using the UV sensor, and if the UV gets a certain level, it closes your window. Yeah, that'd be fun.
I like it.
Awesome. Thank you. Another question from the chat from CMAC. How do you configure the marine sensor to use the pressure sensor to measure depth in water? Does it measure salinity?
So depth is something that's recorded directly from the marine sensor using that pressure sensor. So it's already calculated and that's given to you in the data file.
Mm-hmm.
I don't remember the other part of the question. Sorry.
Oh, that's fine. Does it measure salinity?
No, it does not. So the pressure sensor is just to measure pressure. I'm saying it sounded like they're asking, does the pressure sensor calculate depth by salinity? It's just a straight relationship. There's just a simple formula to get depth, and that is saved into the data file already. So so that's interesting though, because salinity, conductivity, pH are things that we've heard people want to add, and those are sensors that could definitely be added to it. Reprogram the microcontroller to use those and store that type of data from those sensors.
Yeah, just configuring it to fresh or salt water when you are doing the configuration for the GoSense Marine. There's built-in constants in there that are used to calculate depth. But if you had a way to measure that, you could pull that into the same equation instead.
Beautiful, thank you. Yusuf asked, what is the difference between the Air Plus sensor and the marine sensor?
The biggest difference is that the Air Plus sensor should not go underwater, but the marine sensor is in a watertight enclosure, so your electronics stay safe. While both do temperature and pressure, the marine sensor will do additionally TDS or total dissolved solids and turbidity if you get those add-on sensors.
And the temperature sensor that is on the marine sensor is really designed for fluids. You can get, it will, if it's in the air, it's giving you a reading. It's not very fast responding. It's rubber coated, but it's a whole lot better in the water. So because it's got the body, it's got fluid all around it. So that is also a primary difference in the type of sensor. Plus waterproof. Please don't see if your GoSense Air Plus is waterproof. We guarantee it's not.
Thank you. This is a question from CJ. Could we put the marine sensor on our RoboSub?
Please. That was our goal at RoboSub this year, and we just didn't work with any teams to make that happen. But you could add sensors to it then. That is another control thing. Going back to a former question, could you control something? So since you've got pressure and depth, if you had it on an ROV, sea perch or something, you're getting that reading. You could actually put a IMU. That's a small sensor that is measuring acceleration and not necessarily position, but like a vector of heading type position. So you've got information there that you could then use on an autonomous or on a remotely operated underwater vehicle.
As the marine sensor stands, there's not like a connection point to connect that sensor data back to your vehicle, but you could use one of the blank penetrator spots if you're not using it to pass a wire through.
Right.
Thank you. This is from Jay Sproul. Could you please share a few marine application success stories, if you have any?
The one success story was with Blue Robotics using it and collecting real scientific data. Trying to think if anyone has gotten any information to us with the marine sensor. I can't think of any other ones. We did have, and Katie, you're probably more familiar with the paper someone wrote with the air sensor, the original air sensor. They were studying cancer in the area because that one had an air quality sensor on it. The new one does not. So a student, I can't remember what grade I think they were a high school student, measured, different air quality, and they were relating that to cancer in the area. Going back to that, so if you're interested in air quality, you could buy a $20 air quality sensor Adafruit and put that on and then reprogram it to get air quality for you.
Perfect, thank you. The next question is from Yusuf, and I think he might be talking about the competition. We can use these on a sea perch. Is that allowed in the rules?
It would be in the open class because of the expense of the sensor. So we'd love to see that, but yes, that's not disallowed, not prohibited. That'd be great.
Perfect. And this is from CJ along those same lines. Could you make a challenge with this? Like what RoboNation teams collect the most data in a given year? Something like that. Would that be something you see happening in the future?
Cheryl or Katie should write a note on adding that and see if we could see if the whole RoboNation team could come up with something, right? It's a good idea.
Yeah, that is a really good idea. Yeah. And we have one more question. It's from Yusuf. And does this support any other controller like Node MCU, or is it just Arduino?
It can be programmed with, I've programmed it with micro Python and with circuit Python. It can be programmed with Arduino, of course, block programming. So it's pretty versatile. Anything you can program the Raspberry Pi Pico with, you can program this because that is actually the microcontroller. So yes.
Okay. Well, this looks like all the questions we had. That was fantastic. Thank you. And before we finish up, I want to thank you all for joining us today for an introduction to GoSense, and a special thank you to David and Jamie for sharing their time and their ideas. If you have any other questions or want to follow up, just reach out. All the resources David and Jamie have talked about are on our website, and our team is always here if you need support bringing GoSense to your students. We're excited to see how you are going to use GoSense in your own classrooms and programs. And if you'd like more ideas, join us next Thursday, November 18th at 4 p.m. Eastern Time for our GoSense curriculum webinar. You'll get to meet our STEM ambassadors, Derek and Carlos, and see even more ways to get started. Thank you again for being here, and enjoy the rest of your day.